Hey everybody. This week we are going to talk about hypothesis testing. And actually, this is the last big topic we will be learning. This week we'll be doing hypothesis testing, and we'll also be doing it next week, just with a different type of statistic. So we're going to have about 2 weeks to work on this content, and it's the last big piece, and then we're going to have finals. And so yeah, hang in there. We are almost done. This is just the last little bit. Just keep chugging through. Summer will be coming soon enough. And then we'll maybe still be stuck inside. Hopefully not. We'll see. So let's get started. This first section is just an introduction. We're going to talk about some keywords, vocab, how this whole thing is going to work, and then in the next section we will actually start solving some fun problems. So, first definition: a hypothesis is a statement or claim about a characteristic of one or more populations. I'm sure most of you have heard this word before, hypothesis, probably more in regard to the scientific method. And it's the same idea, we're making some sort of claim, and then we're going to test that claim to see if it's true or not. And how are we going to test it? With an hypothesis test. It's a procedure based on sample evidence that is used to test a statement or claim about a characteristic of one or more populations. So we're going to use a hypothesis test to test our hypothesis. So anytime we start setting up these hypotheses tests, I don't know, that sounds weird. But any hypothesis test we set up is going to have two key pieces: a null hypothesis, which we denote with this H sub 0. And by the way, I'm saying H sub as in like subscript and then 0. And then alternative hypothesis, we call that H sub A. So every hypothesis test is going to start with these two pieces. What's the difference? So the null hypothesis is a statement about the value of a population parameter. This statement is assumed to be true. I'm going to highlight that. Ooh, I highlighted up there too. That's fine. It's assumed to be true unless we can find sample evidence to indicate that it's not. So yeah, the null hypothesis is what we already believe to be true. And then the alternative hypothesis, that's another statement about the value of a population parameter, but more specifically, this is the statement or claim that we are trying to find the evidence to support. So this is what we're trying to prove. So let's look at a real world example, and then we'll dig into some, examples that more apply to this course. But in the real world, think about our current justice system. If someone's charged with the crime, the defendant, and they go sit in front of a jury, we are supposed to assume the defendant is not guilty, right? Innocent until proven guilty. That's technically what we should be doing. That doesn't always happen because we're humans, but we're supposed to assume the defendant is not guilty, and that would be the null hypothesis, that we assume the defendant is not guilty. But then it is the job of the prosecutor, generally, to prove beyond a reasonable doubt that the defendant is guilty. That's what they're trying to prove in a court trial, right? They're trying to prove that this person is in fact guilty. And that would be an example of the alternative hypothesis. So once again, the null hypothesis is what we are supposed to assume is true. But, we've come upon some evidence that maybe supports the idea that it's not true. So the alternative hypothesis is what we're going to try and prove with that evidence. So that's a real world example. And before we get into some statistical examples, I have this little chart here. So there are 3 different main different tests I guess we'll run into. Um, well, okay, it's actually two, a two-tailed or a one-tailed. But then if we have a one-tailed test, it could be either a right-tailed or a left-tailed, right? It's just about where is the tail living, on the right or the left. And I have some pictures that I'll show you shortly, but at least here you can kind of see how these hypotheses are set up in these different situations. So if you'll notice, this first column here, or this second column really, is the two-tailed column. We have mu is equal to, now here we have mu not, but that in, an actual problem, that would be a some value. Mu is equal to some number. And if you look all the way across, they all have mu is equal to some number. Mu is equal to some number. So when we create or, write our null hypothesis for these tests, the null is always going to be mu is equal to. And then you got to figure out what that value is from the problem. But then if you look at the alternative hypothesis, this is where things change. And again, it all depends on the wording given to you in the problem, which is why we'll be doing 3 examples below. But we could have an alternative hypothesis where we believe that the mean is actually different from the proposed or claimed value. We could have an alternative hypothesis where the mean we believe is greater than the proposed value or less than the proposed value. So these are the 3, I guess, main forms you'll run into when every time you need to write your null and alternative hypotheses. So let's just do an example. Number 1, state the null and alternative hypotheses for each scenario. Number 1, a manufacturer of banana chips would like to know whether its bag filling machine works correctly at the 434 gram setting. Is there sufficient evidence at the 0.02 level that the bags are overfilled? Assume the population is normally distributed. So anytime we are setting up for our hypotheses, this is what I like to do. H sub 0 for our null, and I do like a little colon because we're going to write it next to it, and then H sub A for the alternative. Now remember, at least for right now and in this course, our null hypothesis is going to be mu equals, and then we just got to figure out what this value is. So remember, the null hypothesis is what we are claiming to be true, or what we're already assume is to be true. And if we read this problem again, a manufacturer of banana chips would like to know whether its bag filling machine works correctly at the 434 gram setting. So it sounds like they made this machine to work at that setting, 434. So that's what we are assuming to be true. That we assume the mean is going to be 434. The average, once all those bags are filled, on average, each bag is filled with about 434 grams. However, they want to know, is there sufficient evidence at the 0.02 level? This level business we'll talk about shortly. Don't worry about it right now. But is there sufficient evidence at that level that the bags are overfilled? Keyword there, overfilled. I should have highlighted, but I'm going to underline. So this is what we're going to use to build our alternative hypothesis. So it's going to start with a mu, because they all start with mu. But then, we have 3 options. Is it a not equals? Is it a greater than? Is it a less than? Well, they want to know if the bags are overfilled, as in, are they being filled with more than 434 grams? So that is the greater than symbol, right? So we're going to test to see if the bags are being filled more than, with more than 434 grams. So that is our null and our alternative for problem 1. And we got 2 more to do, so if you're still a little confused, just hang in there, or let's do all 3, and I think it'll start to click, if it has not already. So number 2, an automobile manufacturer claims that their van has a 45.3 miles per gallon rating. An independent testing firm has been contracted to test the MPG for this van. After testing 25 vans, they found a mean MPG of 44.8 with a standard deviation of 1 MPG. Is there sufficient evidence at the 0.05 level that the vans underperform the manufacturer's MPG rating? Okay, so there's a lot of numbers going on in this problem, and the goal, we have to pick out the right ones, right? What are we trying to focus on? So let me at least get this part started. We're going to have a null, we're going to have an alternative. So one key thing you want to look for when trying to write your hypotheses is, so like the null hypothesis is what we are assuming to be true. And if we read this very first sentence, an automobile manufacturer claims that their van has a 45.3 miles per gallon rating. That's what they're claiming. Keyword, they're claiming that their van has that rating, 45.3 miles per gallon. So guess what? That is our null hypothesis. So if you run into a problem where they're saying, well, this was designed to perform at this level, or they claim that it works at this level, that's your null, because that's what we're assuming to be true. So for our null hypothesis, mu is equal to 45.3. Now, our alternative hypothesis. So if you keep reading, you'll notice if we look at the sentence that begins with after testing 25 vans, I feel like there should be a comma right there, they found a mean MPG of 44.8 with a standard deviation of 1 MPG. So this sentence contains data about a sample. And we will be using this data, but later on in the hypothesis test process, we will have to use sample data to create a test statistic. But we don't use the sample data for our null or alternative hypotheses, okay? The sample data will come in later. But we still have to figure out this the alternative, right? Is it going to be a not equals? Is it going to be a greater than? Or is it going to be a less than? Let's keep reading. Is there sufficient evidence at the 0.05 level that the vans underperform the manufacturer's MPG rating? So underperform. Under. What do you think will go with under? Less than, right? So are the vans actually performing at less than 45.3 miles per gallon? And that is our null and alternative hypotheses. Now notice these numbers are the same, right? They don't change between the null and alternative. What's changing is really this sign in the middle. Boom. And that's what you really want to, this is what you got to figure out. Well, once you figure out what the actual number is that we have to pull out of the problem, then you have to worry about, for the alternative, what operator are we going to be using? So keywords, right? For number 1, where we had greater than, they use the word overfilled, right? Over, greater than. For number 2, we had a less than for the alternative hypothesis, and they use the word underperform, right? That corresponds to less than. So there will be keywords in these problems to help you figure out which operator to use.